Good morning and good afternoon to the folks on the East Coast. Good morning to everyone else. Thank you all for joining us today. This is Origin and Cause's 5th annual national tour. Typically, we, as you know and may have attended, we usually do these live events going to various cities across the country. This is our second digital edition, and we hope maybe next year we can do a little bit of a hybrid version, both online as well as in person. Every year when we actually put on this event, a lot of preparation goes into it. And one of the big things that we really focus on is picking a theme that is relevant and based on what we're seeing in the field. And with so many people at home in the past 18 months and a lot less people sitting in commercial spaces, we're seeing a huge influx, or we've seen a huge influx in commercial and large losses. While there's been a decrease of residential losses. So we thought complex claims is really what we need to speak to. And complex claims come in all different shapes and sizes, usually involving multiple stakeholders, but not always the same ones. The only consistent thing in complex claims is unpredictability, and that there's a lot of changes that take place, but there are fundamentals, things that don't change, that we want to make sure that we cover with you guys and speak to you on. We had our first installment of the national tour last week, and we got incredible reviews from those that attended. People were very engaged and very pleased with the preparation that the presenters put forward, and were engaged with the content. Thank you so much for those reviews. And we're really excited to talk about a very unique set of topics this week as well. So sit back, relax, take notes, and welcome to Origin and Cause's national tour on complex claims. So this year, we celebrated our 30-year anniversary and pledged to raise $30,000 for Habitat for Humanity at Origin and Cause. And as part of that effort, we're donating $15 on behalf of each of you today. Anyone that has attended the national tour, we will be donating $15 in their name. And we're honored to make this donation on your behalf and appreciate you coming out. Based on the, so far, I think we have raised in the national tour around $7 grand. So that's really exciting for us. Quickly, I wanted to talk to you about what's going on in BC. Origin and Cause is engaged and mobilizing our staff and experts out there to make sure that BC gets the attention they need in this catastrophe. We have several experts that are ready to jump in. We have civil and structural and geotechnical examinations that we're able to conduct for, obviously shifting soils and grounds, and as well as looking at structural integrity of buildings. And even when it comes to potential rebuilds, shoring practices, these are all things that we can assist with. Inspecting electrical equipment installments, a lot of mechanical equipment assessments will be needed when it comes to even fuel related appliances and stuff. Those are certainly things that we can assist with. And drone inspections. Drone inspections could be very high level views of regions and areas. We have very sophisticated instruments to take measurements, very precise measurements of buildings and such. But also drones can be used internally inside homes and commercial properties to reach hard to reach places such as basements and crawl spaces. We have very precise capabilities of flying and also documenting scenes and taking measurements. Just wanted to give you guys a heads up about that. If you have any questions, please email me, and I'm happy to answer your questions and put you in contact with anyone that that you need. So just wanted to let you guys know, as I'd mentioned, Origin and Cause has been established for the past 30 years. We are the largest forensic engineering and fire investigation firm in Canada, with 17 locations and over 40 forensic experts in all of these geopinned areas. Our expertise, we have services all across major engineering disciplines: fire and explosion investigation, structural engineering, chemical engineering, material engineering, electrical engineering, mechanical engineering, accident reconstruction, drone services, and forensic litigation services. We also develop a lot of content, a lot of articles and webinars throughout the year, and they're all on our website. I encourage you guys to go check them out, origin-and-cause.com. And they're designed to kind of be read within 5 minutes or so, the articles, and they are really great. We get amazing reviews from adjusters and lawyers and risk managers about them. So today we have 3 presentations scheduled. Number 1, complex electrical claims. And then the second presentation will be on petrochemical fires and repairs. And the last presentation will be on complex mechanical claims. So I wanted to just very quickly go through some housekeeping items. So in order for you to submit questions, we'll be having Q&A period after every hour of presentation. So people were last week submitting questions in the chat. You can submit kind of discussionary things in the chat, but in order for us to run the Q&A, we ask you to please click on this Q&A button, and that's where you would submit your questions that would be answered by the experts. And we are going to be sending you completion certificates next week. So just letting you know that they won't be sent out within this week. It would be next week. And if you're having any technical difficulties, please email us at webinar@origin-and-cause.com. And just one last thing, if you guys, when you are submitting questions in the Q&A console there, or the button there, typically the questions that are asked first are the ones that get answered, because we typically run out of time in the Q&A period. So don't wait till the end to submit your questions. As they come to mind, please submit them if you want them getting answered. All right, let's jump into our first presentation, being complex electrical claims. So I'm very excited to introduce to you our first presenter. So today we have Martin Coles joining us from Edmonton. He has 15 years of industry experience and has conducted over 300 forensic investigations. He has been accepted as an expert in court, and his technical specialties include fire investigation, electrical and electronic failures, product liability claims, and alarm system analysis. So I'll pass off the mic to you, Martin.
Thanks very much, George. Hello, everybody. Thanks for joining the webinar today. I'm pretty excited about this presentation. So I have been asked to talk about, as George said, complex electrical claims. There are, of course, some inherent complications with electrical failures from a technical standpoint, for sure, because sometimes the signs of failure can manifest at a distance from the actual root cause. Sometimes once power is removed, things can change physically, and it can sometimes even be difficult or even impossible to distinguish electrical causes from just the effects of a fire. So all these things contribute, and then Also, electrical claims, of course, can be subject to all sorts of legal, logistical, safety, and other kinds of complications that aren't necessarily present with other types of losses. So I've selected 3 case studies here that hopefully will allow us to cover a lot of these various angles. My first case study here is about a personal injury litigation file involving an electrical injury. So here's a summary of the information I was given when we were first retained. Basically, this was a sorry about that. This was an injury to a toddler in a rented house that she was living in with her family. It involved a double-plugged extension cord. Sometimes that'll be called a male-male or a double-male extension cord. This cord was connected underneath a built-in cabinet, and the unconnected end was sort of hidden under or behind this cabinet. And this cabinet that we're looking at here is the one in question. The toddler, through a litigation guardian, sued the landlord, the property manager, former owners of the house, as well as some other parties too. There were also several third-party actions between those various defendants. So I was retained by counsel for the toddler. I would like to warn you about this. The injuries were quite severe. I'm not going to get into graphic details or anything, but suffice it to say that this was a pretty unpleasant situation. Another thing was, at the time, both the lawyer I was working with and myself were new parents. And so we had to work pretty hard to keep our emotions in check and focus on the technical details of the file. So basically what happened was that the child was playing hide and seek with an aunt who was babysitting. She went behind the cabinet over here, sort of between the cabinet and the wall. And then when she didn't come out, the aunt went and found her there injured. So yeah, this took place over in this area here. The girl suffered severe injuries to her mouth, face, and one finger. And these injuries involved permanent scarring and damage to her face and her mouth, which limits movement and expression of her face. So this incident, particularly around the time of the trial, became a news story in the Vancouver area, attracting attention from quite a few media outlets. But this was largely because it involved an offshore landlord who, like a non-Canadian landlord, during a time of very high housing costs and a wider public debate around foreign housing ownership. So here's a model of the cabinet that was involved, showing the electrical installation to it. As I said, I was retained much later than the incident, so I only received a few photos that were of kind of questionable quality, and had to generate this model myself based on information that I kind of cobbled together. So the cabinet was built in, and apparently it replaced a pony wall at the top of the entry stairs by the front door. During trial, it was determined that the cabinet was originally constructed before the defendant landlords owned the house, but was likely modified by tenants at some time after the landlords purchased the house. There was an electrical outlet box mounted underneath the cabinet, and that was down here near the middle of the unit, with power being supplied from under the floor over here. I believe that junction box may actually have been repurposed from the pony wall that the cabinet replaced. And then there was the double plugged cord that ran from that outlet through the bottom cavity of the unit over to this end. And then there were also two duplex outlets that were mounted to the cabinet in a pretty rough install. So one here and one up here. And these appeared to be intended to power stereo equipment. But there was the way that this was built, there was no sort of legitimate way to power them. but it is possible to power them with a double plugged cord. Basically, if you plug an energized cord into one outlet on a duplex receptacle, the other outlet will become energized, allowing you to use that one normally. So these are the main items that I was asked to address by my client. First of all, what violations of the Canadian Electrical Code existed here? So they wanted a description of these. And the main issues were with supportive cables. There was power cables need to be supported, stapled to a joist or a stud every so many centimeters, that sort of thing. The next was the fact that that junction box underneath the cabinet was concealed and not visible for maintenance. And the third was the improper use of a flexible cord. And a flexible cord is the term that the code uses for basically extension cords. So the next question was, did these code violations constitute a hazard? And I mean, the flexible cord issue, of course, was the biggest one. But the fact that the plug box, that junction box there, was concealed meant that a casual observer wouldn't necessarily know that there was power to the cabinet. The flexible cord violation, though, was it did violate a rule that says no flexible cord may have exposed energized elements if one end is connected to power. And interestingly, I went back, I looked at this rule historically, and this rule has been the same for all relevant code additions since 1954 at least. That was as far back as I went, because that was the code that was in force when the house was built. So the third thing that I was asked to look at was whether the actual injuries match what would be expected in theory. And so in order to address this question, I had to refer to research on electrical injury. The thing that made this difficult, though, was that most of this work is done for workplace safety purposes. Most of the research is on workplace safety. So I had to make some assumptions, scale things down to the smaller body size of a child. But after doing some calculations, we found that the injuries did indeed match theoretical expectations. We also found that the currents involved would likely be certainly high enough to cause significant damage to tissues, but would likely not be high enough to trip the circuit breaker, which allowed the current to continue to flow despite this incident occurring. So here's a picture of the actual cord that was involved. As you can see, there's two plug ends here, one with tape on it. So the main three things I noticed with this cord was, of course, the cord has two plug ends. The second thing was it was just made from a very light duty cord called lamp cord. Oddly enough, lamp cord is an actual technical term. And the third thing that I noticed was that it was clearly 100% homemade. Basically, the two plugs matched, so it's unlikely that it was a cord that was bought and then one end cut off and replaced. It was 100% homemade, so it was made with intention to do this for sure. The tape around the one end was to attach it to that outlet box that was down underneath in the middle of the unit. And I did also find some blistering on the non-taped end that could have occurred during the incident. So looking at this, you might be wondering what other reasons a person might have to make one of these. And the most common reason we see is for Christmas lights. If a person spends a few hours stringing up Christmas lights, and then when they're done, they find that they put the receptacle end beside their outlet rather than the plug end, often people will look for unsafe solutions rather than deal with the frustration of completely restringing it, or you would hope just go get a longer extension cord to connect the far end. Yeah, and the other main use that we see for these kinds of cords is to connect generators to house wiring during a power outage. Like I said earlier, if you connect one end to an energized end to, say, the bottom half of a duplex receptacle, the other will become energized. And that works for a generator, and it actually works on a wider scale than that. If you plugged a generator into your outdoor outlet with one of these cords, then the outlets inside your house would also be energized. And the big hazard that this causes is for utility workers working to restore power during a blackout, because they can then the generator can backfeed into the power lines, and the utility workers can encounter energized lines where they're not expected. So back to our particular issue, there were a few non-technical issues that really became significant during the trial. Number one, of course, who created this hazard? It was determined at trial that it was likely created by a previous tenant of the residence, but a specific individual could not be identified. And there weren't sufficient records to go through every previous tenant of the place. Number two is, did anyone know of the hazard? Now, it is considered possible, again, that other previous tenants were aware that this hazard existed, but none were specifically identified. The owners had never even set foot in the house. Like I said, they were offshore owners, property owners, and so of course they were not directly aware of it. And the property manager also testified that she was not aware of it. So number three, whose responsibility was it to know of and correct this hazard? Now, the property manager was actually the sister of one of the owners. It was a married couple who owned the house. And the property manager was the sister was kind of informally working as a manager. The court determined that her inspections should have been more rigorous and that she should have looked deeply enough to at least find something odd there and hopefully retain an electrician to dig deeper. In particular, the court determined that these, like the roughly installed outlets, and this is unfortunately the best image I have of it, this one that's circled here. If there's no furniture or boxes or anything in the living room, that would be clearly visible. And so they determined that she should have, seeing this should have sort of raised a red flag for her. So basically, during the trial, it was found that the main hazard was created after the owner purchased the house, and that it was not possible to determine exactly who created it. It was considered likely to be a former tenant. So given that no one knew that the hazard existed, the question becomes who should have known. So what the court determined was that the two owners and the property manager were each found 1/3 liable. Because they determined that the property manager should have conducted more thorough review of the property between tenants. During trial, I was actually the only expert that was retained by any of the parties. And of course, I had to work based on pretty old information. The assignment to me came several years after the incident occurred. And interestingly, what happened was during cross-examination, counsel for several of the defendant parties seemed to be trying to use me as their expert that they didn't have to pay for in order to go after the third parties they were targeting, rather than really attacking my technical position. My client was fine with that, but a couple of times I did have to sort of push back on the questions that I was getting, because they were trying to get me to discuss the things that were really beyond my expertise and beyond my mandate. The best example of that was that there was a big discussion about whether or not whether the general construction of that cabinet unit was poor or amateurish. Now, of course, I'm not a cabinet maker. I've seen furniture. I live with it, that kind of thing, but I'm not a furniture expert by any means. And I only reviewed photos. I never actually saw the thing in person. So I wasn't able to provide any kind of opinion on that. So it certainly was an odd, very intense experience in the stand there, but in the end, it did wind up settling favorably for my clients, and they were pretty pleased with how the testimony went, even with all those sort of strange developments on the stand. So move on to my next case study. This involves a failure of a distributed heating, ventilation, and air conditioning system in an elementary school. So the background on this one is that it's a school in a small remote town. This town is sort of located at the end of a road next to a mine. So all infrastructure, power, and everything follows this road, serving the mine and the town that was basically there to support the mine. There was kind of an unusual HVAC, and as I said, that's heating, ventilation, and air conditioning. An unusual HVAC system in the building. There was a distributed heating and cooling unit, an independent heating and cooling unit in each classroom. There were 13 classrooms in the building, including the library. Heat and fire damage were identified in 12 of the 13 ventilation units. The school was affected by a widespread power outage over the weekend, and then smoke and fire damage was discovered on Monday morning when first staff arrived for the school day. So this power outage that occurred affected about half of the town, including the school. Direct fire damage was pretty limited. It was only found inside those HVAC units in the classrooms. So there was no direct structural fire damage, but smoke damage affected pretty much every part of the school. As you can see in this picture on the left, smoke settled on basically every available surface in the building. So this included student and staff property. So all student property had to be either cleaned or replaced. It also included all of the fixtures and fittings and contents of the school. Think about things like library books, textbooks, bulletin boards, gym equipment, not to mention computers and AV equipment. So it became a very large claim with a lot of small stakeholders, as well as the one large school district stakeholder. So this incident occurred in late May. So they made no attempt whatsoever to reopen the building before summer. But still, that means that the next school year is only 3 months away. So there's a lot of work to be done before they can reopen for the following school year. Direct fire damage inside the ventilation units is, you see it here on the right. And these arrows are pointing at VFDs, which are variable frequency drives. Each of these ventilation units had 2 of them. I'll discuss those a little bit more in the next slide. But of the 13 classrooms, as I said, there was fire damage in ventilation units in 12 of them. So this made everyone really curious. I mean, what protected that one room? But once I got on scene, I found that it wasn't such a specific room that was protected. It was actually that 18 out of the 26 VFDs were damaged. And it was just by coincidence that 2 of the 8 undamaged units happened to be in one classroom. Actually, this picture you can see here, there's one that's significantly damaged and one that is pretty clean. So what are VFDs? As I said, that stands for variable frequency drive. And so these are used to control the speed of AC electric motors, so alternating current electric motors. And typically AC electric motors, because of inherent technical limitations, are usually used just for single speed purposes. Things like elevators, home furnace fans, power saws, that kind of application, where basically you just need one speed for the motor to go. But with a VFD, it takes incoming power and it changes the frequency of the wave. Typically, you're dealing with 60 hertz out of the wall. So 60 waves per second of power. But the VFD can take that and it changes the frequency and that adjusts the speed of the motor. The thing with VFDs, though, is that they are pretty sensitive to poor power quality, especially if you're dealing with three-phase, like high three-phase power for large applications like this one. If they're exposed to unmatched power phases, they can react badly. The use of VFDs in a non-industrial setting is pretty unusual. In modern residential and commercial settings, they are generally there are other solutions that are used. But at the time of construction of this school, some of these more modern alternatives were still very expensive or not available at all. The images here, I've got one showing, of course, an undamaged unit, one with patterns indicating heat from inside, sort of a partly damaged unit, and one that heated right to ignition. These devices for scale, they would fit inside your hand. They're about 2 inches by 2 inches by about 4 inches. And I do want to point out, yes, I am showing legible markings on these, but I don't want anyone to think that in this instance, the VFDs were defective. I'm not accusing this company of anything by any means. They were just exposed to input power that they can't cope with. Also, had the fault been involved a defective unit, I would only expect one of them to fail rather than 2/3 of them. So as I mentioned in the background information, there was a power outage immediately before the failure was discovered. This incident occurred in British Columbia. So information from BC Hydro, which is a Crown corporation, is available through a FOIP request, a Freedom of Information request. So that data that's available does include smart meter data. As I was representing the school district, it was easy to get their permission as account holders for BC Hydro to release that data. So the power records that we obtained indicated that one phase did completely fail during one of the 3 phases completely failed during the outage, while the other 2 remained on. Power on the phases that remained on dipped by up to 75% of nominal voltage. The fuses protecting these VFDs were slow blow type, not the typical fast acting. We found that no equipment other than the VFDs had damage, and the power conditions would be expected to lead to failure, heating, potentially fire in VFDs. So VFDs can be damaged if one phase drops to about 80% or below relative to the others. There were also wild fluctuations over time. This was a power outage that sort of came and went with large fluctuations in power. So it is possible that ordinary fast flow fuses might have protected these VFDs. But generally, it is standard practice to put slow blow fuses on circuits for motors because they have high startup currents. So when you first turn it on, they draw a lot of current for a very short time. So these startup currents, they don't typically endanger the supply wiring, even though they exceed the nominal levels that the supply wiring is designed for, because they're very short duration. But they can expose equipment like VFDs to larger input variations than they can handle. So the main complications involved here were basically the sheer quantum of the loss. It was it affected so much of the school. There was one major party, as I said, it's the school district that's self-insured, but then hundreds of other parties experiencing a small loss, meaning the students and staff. And then the school, of course, is interested in subrogation opportunities for this loss. So you might first think that the subrogation target might be BC Hydro, but the thing is, like most power utilities, their terms of supply are pretty ironclad. you pretty much have to prove that they caused the damage deliberately in order to successfully recover. At first, this can seem pretty unfair to customers, but then once you think about it, if that protection didn't exist for power utilities, it would be extremely difficult to convince anybody to be a power utility. Secondarily, the school district, of course, is a public entity, ultimately controlled by the province, and BC Hydro is a crown corporation wholly owned by the province. So this likely also reduced the appetite for pursuing subrogation against them. There were considerations of going after the designer of these HVAC units, but the school and the HVAC system was pretty old. And all the maintenance work since then was done by school district staff, including fuse replacements. So in the end, the district just had to accept the loss and kind of move on. Yeah. But so my last case study involves a fire in an electric vehicle that was located in an underground mine. So I imagine you can see why electric vehicles would be attractive to a mine operator. They produce no emissions that would then need to be ventilated out of the mine. And they also don't require fuel to be brought down into the mine. Ultimately, this incident notwithstanding, they are really an excellent solution for that application. Also, a fire involving an electrical vehicle, while obviously far from desirable, is fundamentally less hazardous than one involving a gas or diesel-driven vehicle, or potentially a refueling station. So the background on this one is a fire occurred in an electric vehicle in an underground mine. This vehicle was based on a commercially available chassis and body that was then modified to be an electric vehicle. The vehicle was parked. It was not on charge at the time of the fire, though it had experienced some charging issues and appeared to be causing a ground fault in the weeks leading up to the fire incident. Flames were already venting from the vehicle when the fire was first observed, and the fire was extinguished and then cooled with briny water, so very salty water. It's a mining byproduct. So this fire was first identified by a mine staff member in an office, which was basically an ATCO trailer that's placed down in the mine. And it was around the corner from where the vehicle was parked, so not with a direct line of sight at the vehicle. The staff member heard some popping noises and came out to see what was happening. As a result of the fire, the mine had to fully evacuate, shut down for a couple of days. Small number of miners were not able to evacuate before the fire was extinguished and had to shelter in refuge compartments. These spaces have supplies of food, water, and air. They also have internet, so miners are able to communicate with their families. The fire did affect a section of electrical wiring strung along the ceiling of the mine drift. So a portion of the mine was without power for a short period, but fortunately these areas were not active production areas. So here's a picture of the vehicle post-fire. As I said, it was located in a mine drift, which is a lateral tunnel in the mine. Now, observed damage to the vehicle did increase towards the engine compartment, and that engine compartment housed the electric motor, one of two battery banks, the charger, as well as a lot of control circuitry. Something to bear in mind with this one, some differences between these vehicles and surface vehicles is you may notice there's no glass anywhere on the vehicle, and the doors aren't solid. And then the other thing to bear in mind is, of course, the engine compartment means different things in an electric vehicle. In this case, it does contain the electric motor, but that's a pretty small unit relative to a gas or a diesel engine. So a couple of the details that we did identify in terms of fire patterns and damage patterns was there was increased oxidation to the front of the vehicle. The rear tires relative to the front were pretty much intact, and there was some protection to combustibles in the passenger compartment. And those are all the observations that really led us to look at the interior of the engine compartment for causation. So the battery pack was below the fast charger, and this arrow here shows that's the sort of the top layer of the battery pack. The charger circuitry, the charger unit is here sitting on top. Most of the major components certainly had damage indicative of exposure to fire, and we did not identify any major electrical damage. We looked through the vehicle for electrical damage on all the major conductors, but there wasn't any on the big fat wires. Small conductors, of course, become very brittle and weak, and they often don't provide a lot of information because they just disintegrate. So the thing we did need to be careful with in this one in terms of damage patterns is that with vehicles, we often pay a lot of attention to patterns involving oxidation of metals. So basically rust that occurs when they're exposed to fire. But in this case, we had to be cautious with those patterns because the fire suppression was done with the briny water, as I said, which will accelerate and exacerbate the oxidation of the metals. So it doesn't mean that those patterns are necessarily misleading, but they don't always mean the same things that they would on a typical fire that occurs on the surface. So the vehicle battery packs were modular battery packs, and we did find greater damage on this left module than on the right. And most cells, the battery cells, were generally intact. We found a small number that were ruptured. So these battery packs do consist of many, many small cells. And these are actually the same cells, battery cells, that are often found in laptops or other relatively small electronics. And the basics of examination for a vehicle with thousands of battery cells rather than sort of half a dozen that would be in a laptop, it's basically the same principle. It's just that you're scaling it up. So essentially, you look for differences in levels of damage. And then you have to ask yourself if those differences can be explained by factors external to the battery, like fuel load concentrations or exposure to a fire not involving the battery. And if the signs you're seeing can't be explained by those external factors, then chances are you are looking at a failure internal to the battery pack. And most commonly, that is a single cell failure that creates excessive heat, leading to what's called thermal runaway in adjacent cells. So thermal runaway is a feedback loop effect that occurs when one cell has a small failure that generates excessive heat. So this leads to an increase in the battery chemical rate, because when batteries get hot, they sort of run faster. And that increase in temperature leads to higher electrical currents, which leads to more heat. And the loop continues like that. The effect can start in a single cell and then spread to other nearby cells. So in terms of the challenges for this examination, there's a lot of site-specific challenges involved in this situation. Of course, there's many special precautions required for an underground location. We only had elevator access. There are also a lot of regulatory requirements involved with working underground, with fairly in-depth orientation from the mine. But of course, with support from mine staff, I was never unescorted. I did have to go through orientation at everything, but not the full orientation that they're required to be independent in a mine. The other complications involved involves battery pack handling. So we need to consider the possibility that some cells are still sufficiently intact to still carry charge. So what we did was we used thermal monitoring, and this picture shows just a thermal camera. So we had a person the whole time we were doing the investigation. We had a person on that thermal camera looking for hot spots. We also had fire suppression on standby. And then, of course, the disposal for these battery packs needs to take into account that there may be a few of them that still might be energized. So what we wound up doing was we had to pack these batteries. Each sort of module of the battery pack had to be separately packed in plastic bags, which were then placed in barrels along with a non-combustible packing medium. And then the barrels are sealed up so that they can be safely removed from the mine and disposed of. Because the last thing we want is to just throw them all in the trash and then have another incident involving them. So yeah, they had to be carefully packed. It took a fair bit of research to determine the correct methodology for disposal before we had to do all that before we even were able to get started with the investigation. So those are my three case studies. So I'll pass it over to George now to moderate the Q&A part.
Yes, thank you so much, Martin. Appreciate it. So folks, please submit your questions in the Q&A button there in your console. We have time for just a few questions. The first question is, how exactly did the little girl get hurt? Did she crawl into the area?
Yeah, she crawled into the area without getting into too many graphic details, I guess. She crawled into the area and she did get a hold of the energized end of that cord because the one end was taped to an outlet.
Yes.
Yeah.
Okay.
Yeah, she was like I said, she was very small, just a toddler.
Mm-hmm. So unfortunate.
Yeah, absolutely.
Another cool question. So you had mentioned in the cabinet case, that same claim,
Mm-hmm.
So the question is, what would the response be if your client had objected to you as an expert communicating with other parties?
In terms of acquiring information and so on? Is that what I'm not?
It's a very broad stated question.
Okay.
I mean, you did mention that you were being asked a series of questions and you had to kind of sift through what you would be able to comment on. Was that during court? That was actually
during. Yeah, that was during cross-examination while I was sitting on the stand. Okay. So as I said, that my client could have likely stood up and objected.
Yes.
Like they do on TV. But I mean, he things didn't really get out of control. And he did actually do that in a couple of occasions. But that happens in basically every trial that a lawyer tests boundaries a little bit. But in that part of the proceeding, basically there were a couple of questions. Like I said, I think it was motivated by me being the only expert involved in the case, and the other lawyers just wanted to sort of maybe try to use my expertise to pin something on to be able to exercise their third-party claim and without having to pay for their own expert.
Yeah. I guess when you're on the stand being cross-examined, you don't have the authority to like not answer questions. I guess.
No, you need to have a good reason to not answer it. And I just had to say, look, that's not my expertise. I'm not a cabinet maker. I don't, maybe not.
Yes.
Yeah.
It would be up to the lawyer who represents the interest or represents your client to object to anything that
Absolutely, yeah.
contradict
Yeah,
with-
that would be his job.
Cool, very cool.
Yeah.
Okay, several questions coming in with regards to the cause of the fire in the last example being the
Sure.
the mine vehicle. So what did
Yeah.
you come up with?
So our best determination was that a thermal runaway did occur in one of the battery cells that then spread to others nearby, because we did find a sort of localized cavity of damaged battery cells, that within that array of battery cells that I showed you in the picture. So basically, it looks like there was a single either defect or damage to one of those cells that then sort of spread.
So it didn't relate to a lack of maintenance or anything.
No, it didn't.
Okay.
No.
I see here with a mining example, if briny water was not used to suppress the fire, can you speak to how oxidation of the metal can lead you to good data on the cause? Would this be similar?
Using fresh water, like they likely would do on the surface, and water is for electric vehicles and those large battery packs, water is the sort of the suppression medium of choice. Even though, like, tap water, fire water from a hydrant does conduct electricity to an extent, it is the medium of choice because of its cooling properties. The real goal is to cool the thing down, to remove the heat. But getting back to the differences, really what the standard water you will still expect on steel body panels on a vehicle. With normal water, you will expect a lot of oxidation of those, like once the metals are exposed to fire, they will oxidize, and you'll get those patterns. The briny water, though, would be expected to really accelerate that. And so that oxidation does continue after the fire's removed. And the presence of the salts will just make that carry on faster. So the difference is to get the useful patterns, like after a certain length of time, the slightly oxidized stuff will just look like the very oxidized stuff. And so you'll just want to be able to respond quickly, but when those kinds of accelerations are present.
Okay. Cool. Well, thank you so much. Really appreciate your presentation, Martin. It was great. Folks,
no trouble at all. Happy to do it.
Thank you. We're going to take a 6-minute break, and we will be starting the second portion of this topic. We're very excited about this this next presentation. So, folks, we're going to be starting actually now in 5 minutes. So please take a break and hop back on your screen, and we'll get started again. Thank you again, Martin.
Thanks.
Hey, Matt, just wanted to ask if you can share your screen so we can get prepared.
Yeah, definitely,
Thank
George.
you.
So we'll go here.
Got just a couple more minutes.
Okay, I'm going to share screen one here. And move this over. Do this. That. All good there?
Yeah. Thank you.
Perfect. So yeah, I just heard the end of Martin's presentation. How did everything go? I was sort of on in the background, but
Yeah, it went really well. I'm excited for yours.
I heard that comment, so people stay online to watch
No,
it.
it was genuine. It was genuine.
I was like, okay, he's trying to make people, because it's getting on the lunch hour now, so people might be like, okay, I'll come back for the 1 o'clock showing or whatever.
Yeah. No, we
But I
actually,
appreciate that.
no, of course, of course. We have people coast to coast, so it's
Oh,
1
that's true, I
o'clock
guess.
out east. It's still early in the morning out west, so but anyways, yeah, so we'll start in 1 minute, Matt.
Okay, ready to rock.
Awesome. All right, everyone. So we're gonna get started again. So within this hour, we're going to be talking about key principles of adjusting complex electrical losses. We spoke from a forensic standpoint in the first hour, and then we're going to pick the brains of a senior adjuster. So it's a very different kind of perspective and mentality, a different, of course, mandates as an adjuster rather than a forensic expert. So, I've actually sat in on a couple of dry runs with our speaker, and it's a really fascinating presentation. So I look forward to it. So Matt, if you don't mind just moving to the next slide. So introducing our speaker, Matt Hiller. He is a senior general adjuster. He's a certified fire and explosion investigator with over 20 years of experience. And his areas of expertise include boiler and machinery claims, renewable energy, course of construction and builders risk claims, construction defects and liability claims, commercial property and casualty claims. So without further ado, please welcome Matt.
Thanks, George. Appreciate the opportunity to present today. I'm just going to take it back a slide here to the beginning. As I much prefer this photo of me, it shows my athletic side. So today I'm going to go through some case studies about electrical losses, and more so as to my thought processes and reasons therefore when handling these type of losses. As George mentioned, I do specialize in boiler machinery or equipment breakdown claims for Crawford and commercial property. But the last 10, 12 years, I've been doing more and more boiler machinery or equipment breakdown losses. And yeah, I'm just going to talk about the various thought processes as we have various scenarios that could come about, different pieces of equipment, different situations for the insured, and it's just a different scenario each assignment I receive. So moving on, ways of thinking during the complex claims. When I receive one of these claims, in most cases, you have to expect the unexpected. If not all cases, delays in the repair process are inevitable, especially if there is ongoing extra expense or business interruption exposure. We have to explore all potential options to reduce or eliminate that exposure. And especially during COVID times now, you have delays in labor, delays in material, everything. So even more so, you're going to be expecting the unexpected and coming into delays. Second is to investigate all potential contributing factors to the cause of loss, to the root cause of the event. And that's in order to determine if any other policies might contribute to the claim. And I'll get into that more shortly, but there can be different policies that could respond due to any given scenario. And third, always think outside the box. These loss scenarios may be similar in nature, and you may have similar pieces of equipment, but the insured situation and outside elements can vary significantly when handling these types of losses. So some of the important factors I consider when investigating these types of losses. One, again, determining the root cause of loss and what perils may have contributed to the event. As I mentioned before, in most cases for complex electrical claims, unless it's a very minor incident, we generally engage an electrical engineer in order to assist us in determining the cause of the loss and the scope of repair to whatever piece of equipment we're dealing with. Factors contributing to the cause of loss could be a power surge, lightning, water, etc. Second factor is mitigating damages, especially when there is lost revenue and extra expenses involved. In many of these electrical failures, we have a resulting power outage, which can precipitate to lost revenue for the insured or additional expenses incurred to restore temporary power to the building, i.e. the rental of a temporary generator. The third factor is confirming what coverage is available and which policies could respond. Depending on the cause of the loss or the contributing factors, it's possible that more than one policy could respond to the claim, as I mentioned previously. Again, with the exception of very, very minor claims, it's very important to evaluate all the coverages available under all the available policies that are enforced at the time. And I'll get more into that shortly. So the types of policies that generally will respond to electrical losses. One, we have the equipment breakdown policy, or EBI, formerly known as boiler and machinery, but more insurers are going to the term equipment breakdown now. We have number two, a property policy, which most of you, I assume, would be familiar with. And number three, you might have a combined or hybrid policy, which combines basically the numbers 1 and 2, an equipment breakdown and a property policy. Generally, I would be engaged by the equipment breakdown insurer and be reporting directly to them on these types of losses. But again, I also have a property background, so it can be either one that might retain my services. So first off, I'll speak of the equipment breakdown policy. Generally covers the sudden and accidental failure of equipment, such as a power surge or short in the system. Generally must meet a definition of accident to an object. That is the premise of the equipment breakdown policy. They must satisfy that definition in order to trigger coverage under SAME. So we have an accident, which is generally defined as sudden and accidental failure of the equipment, and object is generally defined as being the equipment such as a transformer, generator, or any underground cables or whatnot. Any electrical equipment really can be classified as an object, or mechanical for that matter, under the policy. So if we have no outside interference contributing to the event, to the failure or loss, the event occurs within the piece of equipment itself, then generally that would be considered what we call a pure equipment breakdown loss, meaning only the equipment breakdown policy would respond if coverage is afforded. We get into other events where there might be outside factors contributing to the event, and in that case, we might have a joint loss among the equipment breakdown and property insurer, which I will get into shortly. So second type of policy is property policy, as I think most people are familiar with. And generally this covers all risks of physical loss or damage. That's the premise of coverage under the property policy. These policies will generally exclude damage caused by electrical disturbances to electrical equipment. If it's some sort of internal failure to the equipment, again, generally the property policy does not respond because of this common exclusion, and it would be referred to the equipment breakdown policy. However, if lightning or water are involved, then there could be coverage for damage to the electric equipment under the property policy. So if you have some outside interference causing the damages or failure to this piece of electrical equipment, that could restore coverage under the property policy, and possibly coverage under the equipment breakdown as well, at which time you might have a joint loss, again, whereas both policies contribute to the event. And thirdly, as mentioned, we have the combined or hybrid policy, which basically combines the equipment breakdown and property policy all in one. In some cases, the equipment breakdown portion of that policy may be underwritten by a separate equipment breakdown carrier that's more used to writing equipment breakdown coverage. And that's all sort of done in the background. Generally, the insured isn't aware of that separate underwriter involved at the time the policy is issued, or even during a claim. I'm not going to get into too much detail on that at this point. So my first case I'm going to discuss involves a backup generator failure at a hospital. And this unit here had failed during a routine weekly testing by the insured. These units do not operate 24/7. They are backup generators in order to provide power in the event of a power outage within the hospital. So the unit was being tested, and during the test, the unit had some sort of failure. You can see the damages here. And the damages occurred to the alternator portion, which is this front portion, as well as the mechanical or engine portion, which is this section here. Following the failure, the insured had rented a temporary generator to connect on site while this unit was down, and that was costing them about $20,000 per month. Again, the temporary generator didn't have to operate during this time. It just sat on site and was connected. In the event they had a power failure, the temporary generator would be activated and provide backup power. As again, this unit has a mechanical portion and an electrical portion, i.e. the engine and alternator. We retained a mechanical and an electrical engineer to assist in determining the cause of loss and scope of repair. It was determined that the cause was to be an electrical failure within the alternator side over here, and thus, and there was no outside interference such as water, lightning, anything like that. So thus we had a pure equipment breakdown loss. No other policies were contributing. So here's a couple more photos. This is the other side of the alternator section and the, I think you call it ventilation grate here. You see a portion of it is blown out and there's some wiring there, and we've got the turbo chargers here. I think that's 2 of them, and the exhaust, which is also damaged in the event. So again, we've got electrical and mechanical damages. So we'd had the engineers prepare a scope of repair, and we engaged a couple contractors who provided repair quotes. We then presented a settlement offer to the insured, at which time the repair should have taken within 6 months, or should have been completed within 6 months of the data loss. And thus the maximum exposure for the rental generator would have been $120,000. Unfortunately, due to unforeseen delays and issues at the hospital, the repair took closer to 20 months, and thus the extra expense claim ballooned to about $400,000. These unforeseen delays involved basically turnover within the hospital. I think we dealt with 3 different operations managers there during the course of the claim. So all of them had to be brought up to speed. And this event wasn't, or the repairs to this unit were not really #1 on their radar when they came into employment of the hospital, as you can appreciate, and they had the backup generator anyways, so they didn't mind just letting that sit there in the parking lot and incurring the cost. But I think we settled somewhere between the $120,000 and $400,000 mark on this, because most of the delays were on their behalf, and that nothing to do with the insurance company. Next case involves a transformer failure at a high-rise residential condo. This resulted in a power outage to the entire condominium building, which I think was about 40 stories, if I'm not mistaken. So a lot of residents without power. Again, they needed to restore temporary power to the building, so the condo corporation rented a generator. This time, the generator had to operate 24 hours a day, 7 days a week, in order to provide power to the building. It wasn't for backup purposes, and that was costing $14,000 per day for the rental and the diesel fuel it burned. If you recall, the hospital was $20,000 a month. This was $14,000 a day. So we've got much more significant exposure. Again, we retained an electrical engineer to assist us in determining the cause, which was determined to be a surge from the hydro supplier's equipment. So really no other outside interference, no lightning, no water involved. So we have, again, a pure equipment breakdown loss, where the equipment breakdown policy was the only one that was going to respond. The engineer had also determined that a temporary repair could be completed on this transformer, so power could be restored to the building while we awaited a new transformer to be manufactured, and thus we would be eliminating the extensive rental generator and fuel costs. So here's some photos here. You see some damages down there to, I believe that's the high voltage coil on this transformer. Here's a closer view of the damage to the high voltage coil and the grounding cable, which apparently got fried as well due to this surge. So again, like I said, the engineer we had engaged unfortunately overlooked some hidden damages to this unit, and I can say that it wasn't origin and cause OCI that we'd used here. So, but the electrical engineer unfortunately overlooked some hidden damages to the transformer, and when the contractors went to do the temporary repair, they'd uncovered these hidden damages, and thus weren't able to complete the temporary repairs. Thus, we were forced to continue using the rental generator at a cost of $14,000 a day. I recall this one kept me up at night. I would just hear that generator chugging the fuel and the noise in my head, and I can't imagine how loud it was at this actual site. But especially after this event when we weren't able to temporarily repair the unit and we had to think of something else. So what we did was we were able to source a temporary transformer that we could install, and that was at a very minimal cost of, I think, about $6,000, a one-time fee to install it. Unfortunately, it couldn't be used permanently. I can't remember why at this point, but we were able to install it and restore permanent power, or permanent temporary power, if you will, to the building without incurring further rental generator costs. I think actually on this one, the insured had exceeded their extra expense coverage for the rental generator costs, and that was a big issue, if I'm not mistaken. Anyways, again, expect the unexpected, and you're always going to experience delays on these claims. My next case involves a hydroelectric plant turbine failure. Now, actually, this was on the mechanical side of the system, but still involves electricity and whatnot. So I thought I'd discuss it. So here we have a hydroelectric plant. It's a 2-turbine plant generating approximately 11.5 megawatts per unit. You see the photo here, which sort of depicts the internal equipment of the plant. And you have basically water that, it's a run-of-river plant. So you go using the flow of the river to generate mechanical energy. So the water would flow in from down here in, and you can't see the turbine or the turbine shaft in here. It's beneath the concrete. Runs along here, generates the mechanical energy, which in turn goes into the alternator portion, I think, and generates the electricity, and then runs out here into the grid. So we've got 2 turbines, one running below here, which is G1 unit, and one running below here, which is the G2 unit. So at the time of the loss, it was during the low river flow season. Only one of the 2 units was operating and was necessary to operate to generate full production. So that was the G2 on this side. We had a failure within the turbine shaft of the G2, and the insured managed to quickly activate the G1, shut down G2 and activate G1 in order to reduce any potential lost production. And again, it was during the low flow season, so only one of these units was required to operate at the time in order to maximize production. However, the autumn or fall high river flow was only a couple weeks away, and thus at that point, both systems would be required in order to maximize production. But unfortunately, we weren't going to be able to conduct the repairs quickly enough to avoid that loss of revenue, which was about $15,000 per day, with only one of the units operating during the high flow season. So this was a combined policy for property and equipment breakdown. So like I said, coverages for both. We hired a mechanical engineer in this case because the damage was to the mechanical side. Here's a better picture of the turbine itself and the shaft over here. So we hired the mechanical engineer to determine the cause, which was a failure, a design failure actually, within the shaft. This unit is about 10 years old, if I'm not mistaken. And the next photos here will sort of show there was a fracture, a crack right here at this point, and it was just a poor design. You can see here it's come apart as they pulled it out. It was a design issue. So we knew that both the G2 unit, which had failed, and the G1 had the same shaft. It was exact same design. So we recommended that the insured replace the shaft in both units in order to prevent a failure in the G1 side. So we proceeded, or had the insured proceed to obtain some quotes from various fabricators throughout North America, I believe, on this one. We provided them with the new design and had them obtain quotes based on that new design. And this happened again during COVID. So again, we don't know what kind of delays are going to occur. And the insured was able to obtain quotes from various fabricators, and two of the lower ones came from a Quebec manufacturer and a Chicago manufacturer. So what we suggested the insured do in order to prevent or try and avoid any delays in fabrication and delivery and installation is we suggested they order both shafts at the same time. That way, if there was a delay with one of them, we'd have the other one still manufacturing the same shaft, and hopefully there wouldn't be a delay from both fabricators, and we could get one in there over the winter time when the river flow is low, and get both units operating before the spring fresh set, which is also a high river flow, and two generating units are required in order to maximize production. So that's what the insured proceeded to do. They put in the purchase order from both fabricators. I don't think there was a delay on either of them. So both the shafts came during the winter months, and we were able to install the shaft in G2 and get that operational while G1 was still operating. And I think the insured was able to take G1 out of production during that time and install a new shaft in that one as well before the springtime when we needed the two units operating to maximize production. So in that case, everything worked out for us, and we were able to minimize the lost revenue claim and move on. So the fourth case I will discuss involves a switchgear failure. This was again at a hospital. This was a arcing and minor explosion within the automatic transfer switch. As you see here, this is the cabinetry for the switch, and these were the damages inside. As you can see, all of the internal components have been destroyed basically and required replacement. The switch was basically switches power over to the backup generator in the event of an outage at the hospital. So in this case, the insured again was forced to rent a temporary generator at a cost of roughly, I think, $17,000 per month. Again, there was no fuel costs as this was just for standby purposes. We'd again engaged an electrical engineer to assist, and we determined that there was a leak through the ceiling in this room. This is the area above the equipment. You can see the insured had installed some sort of mechanism there to collect water leaking through the ceiling and drain it out through this hose here. And I can't recall if that was installed prior to the loss or after the loss. I guess after the loss it wouldn't matter because the equipment was already destroyed. So I think they had the leak, or they were maybe aware of the leak, and I don't know why I can't recall this at this point, but anyways, we uncovered that there was a leak through the ceiling, which means outside interference or outside contribution towards the loss event. So at that point, we had reported the matter. Again, I was on for the equipment breakdown carrier, and we'd had the broker report the matter to the property carrier. based on this outside interference and water exposure, and the property carrier confirmed there would be coverage afforded under their policy as well. And thus, we have a joint loss situation, which means both the equipment breakdown and the property carrier would be contributing to the event and the repair costs. So again, as mentioned, we'd engaged a electrical engineer to assist in determining the cause and determining the scope of repair. Based on that scope, we'd engaged a couple contractors to provide estimates. And based on the estimates, we made a settlement offer to the insured. And based on the timeline of repairs, or the recommended timeline of repairs, we indicated to the insured that we wouldn't cover the rental generator for longer than 6 months. Now, in this case, the insured was preoccupied with another project at the hospital, which was higher up on their list and more so on their radar. So again, they weren't too concerned much about conducting the repairs to this because they had the backup generator connected, and there were no real concerns about losing power to the building and not having backup power. So again, we put it in writing to them. We made the settlement offer and indicated that our contractors had suggested the repair would take not more than 6 months. So we limited the extra expense coverage to 6 months rental on the backup generator. So we're able to mitigate the extra expense exposure for the client, for the insurer. And again, we were able to allocate roughly 50% of the property damage and extra expense costs to the property carrier, thus reducing our exposure significantly to the client, which again is one of the reasons why they hire you is to help mitigate their exposure and, if possible, defer it to another party or another insurer. So again, the purpose of this presentation was more so to discuss key factors and ways of thinking while you're handling this type of loss. As mentioned, in most cases, expected or unexpected delays in repairs are inevitable. If there's ongoing extra expense or business interruption exposure, we have to explore all potential options to reduce or eliminate same. Like I discussed in the in all the cases. I mean, the first case involving the generator, or sorry, was that the transformer? I can't think now. Back to the first case. Sorry, that was the rental or the generator that had failed, and the insured had to rent a backup generator. In that case, obviously, we had significant exposure there from the extra expense claim, whereas the insured unexpected delays occurred as the insured had a high turnover. Like I said, in the 20 months the file was open, we had dealt with 3 different operations managers at the hospital. And again, it wasn't high up on their priority or list of things to do. So they continued to let the rental generator sit there while took their time to do the repairs on the primary generator. And again, that ballooned the extra expense claim to in excess of $400,000. And you see in the later claims, the last case I referred to, we were able to limit that by putting it in writing to the insured and explaining that repairs would only take 6 months, despite the fact that they were in no rush to complete them. And I think they still have a rental generator sitting on site there, but we have confirmed it to them in writing that we won't be paying any more than the 6 months of rental costs for that unit. Second key factor is, again, investigate all potential contributing factors to the root cause of the event in order to determine if any other policies will contribute. And that's, I guess, the fourth case there speaks in that regard, where we had the failure of the automatic transfer switch. And if you recall, we had the water, we discovered that water had leaked through the ceiling and into the unit, thus resulting in the short and failure of same. We were able to report the matter to the property insurer, and they assigned an adjuster and reviewed coverage and determined that, yeah, coverage was going to be afforded under that policy as well. Thus, we have a joint loss, and thus we are sharing in the costs, which were, I think, $400,000 or $500,000 on this one. So we reduced our exposure, the equipment breakdown insurers exposure to 50%, which is great. Obviously, that's what we're here. That's why we're involved, is to try and defer when we can, if possible, to other insurers and get them to contribute. And the third, always think outside the box. Loss scenarios may be similar in nature, but the insured situation and outside elements can vary significantly. And I think all four of the cases that I discussed come into play here. The first one, the generator failure, where you've got three separate, the high turnover in staff, and you're dealing with different people. The second case involving the transformer, where you've got a situation where hidden damages are overlooked and unforeseen. The third case, where we're during the peak of COVID and you don't know what kind of delays you're going to experience in manufacturing and labor or shipping parts across the border. As mentioned, we had to get a shaft built in Chicago, so you didn't know what was going to happen with respect to shipping that across the border. Fortunately, everything worked out. And the fourth case, again, it just wasn't high. The insured had another project on the go, and it wasn't high priority for them. So in all those scenarios, you've got a different situation for the insured and different outside elements. You might have similar equipment, but everything else can vary significantly. So that concludes the presentation. Happy to take any questions at this point. George, I can't hear you. I can somewhat hear you.
Any better?
Much better. I had to mute my microphone. Are you still there?
Yeah. Can you hear me okay?
Yes.
Great. Okay, first question. For the first case, from your investigation, how could we have prevented this kind of breakdown?
That goes back to, okay, that was the generator failure within the hospital. If I'm not mistaken, I'll go back here. And I'm not sure I'm qualified to answer that type of question. This was just, so the insured's own employees tested this unit weekly. It's a backup generator at the hospital, so it's not operating full time, but it has to be tested in the event they do have a power outage. and all they do is start it up and run it for, I think, 5 minutes a week and make sure everything's running okay. Now, if memory, I do recall now more specifically this one, there was indication that this unit was vibrating or putting out some sort of vibrations prior to this event, that either the insured or their maintenance contractor had overlooked. So I guess if the question is how do we prevent this, maybe don't overlook that type of vibration or issues you're having with the unit on prior testing dates, I would have to say. I'm not an electrical or mechanical engineer or whatnot, nor do I operate these machines on a regular basis. I'm just a
Sure.
lowly insurance adjuster who determines or tries to determine when coverage is afforded, and then I hand out checks. But
Sure.
yeah, it was a situation where there was evidence to show that this unit had been, there must have been some sort of vibrations or whatnot before that were either overlooked by the insured or the maintenance contractor.
Okay. Okay, cool. Next question. Was there subrogation because of the design flaw in the shafts?
Yes, there definitely, and I just so happen to stop on that one. So this claim is still ongoing. We've almost finalized the first party loss, and yes, there definitely should be subrogation, and we're just waiting to finalize the first party claim, and then we're going to go after the manufacturer of the shaft.
Okay, great. Next question. Yeah, so it's a similar case of fracture in shaft attributed to poor design. Was there subrogation initiated against the original shaft designer or fabricator? So I
There
imagine
definitely
he'll
will.
cast the net wide and then your pursuit will taper in, right?
Yeah, in this case, it was somewhat interesting as I believe the fabricator and designer were two different companies, but
Yes.
they've since been amalgamated, so it's just one company
Okay.
anyways.
Mhm.
If I'm not mistaken with that one. But yeah, we will definitely we're definitely proceeding with subrogation. It is a significant loss and exposure to the insured who had a high deductible and the insurance companies, which there are many that insure this plant. So
Yes. Okay. That's awesome. Really fascinating case. Next question. How do you approach a fire panel which shorts out and causes a fire to the electrical room? With the fire occurring, damaging the panel, do you push the repair cost of the panel to the property policy or split the cost or cover the panel repairs only?
it was a longer question. How,
How do you approach a fire panel which shorts out and causes a fire to an electrical room? Do you push the repair cost of the panel to the property policy, split the cost, or cover the panel repairs only?
okay, well, in this case, it comes down to the policy wording. Now, generally speaking, I can say if there's a failure within the panel, um, then that repair caused by the failure or damage caused by the actual failure, generally the equipment breakdown policy would respond to that. Resulting fire damage, it gets a little wordy there in the equipment breakdown and property policy wording, and resulting smoke damage as well. Generally, the equipment breakdown policy would respond to your failure event and whatever damages were caused by that failure, but the resulting fire and smoke, especially outside of the panel, to the electrical room or wherever else, generally are excluded under the equipment breakdown policy. And don't quote me on that at this point, but because I deal with many different equipment breakdown and property policies. But speaking in generality, you would have a joint loss there involving both the equipment breakdown and property carriers. So
Cool.
I would, yeah, if I was on for either one, I'd be reporting the matter to the other other
Yes.
insurer and getting them involved.
Cool. On the mitigation on the two hospital losses, if the hospitals are not concerned and there's no impact to their operations, why is there an extra expense owed?
Well, that's just, so there's no impact to their operations, correct. So there's no business interruption per se, but they do have the extra expense of incurring the cost of the rental backup generator. So yes, you're correct that there's no business interruption loss. So there's no interruption to the hospital operations, or there might slightly be, but no loss of revenue or whatnot per se. So there was no business interruption claim or no lost revenue claim. The only claim was for the extra expense of renting the generator or I guess there was no fuel cost in either hospital ones. So they did have that extra expense coverage under the policy. So they made the claim for the extra expense incurred for renting the generator.
Okay.
If that answers.
Cool. Next question. In this current COVID climate, would you recommend insureds with EV coverage to be looking at extending the time that they have coverage?
I assume they mean coverage for extra expenses and business interruption. I'm going to make that assumption that recommend the time to extend that. And yeah, that's a very good question. Wow. I would think that brokers and insurers are probably already working on that or have been, or I'm not even sure, but normally you've got a 12-month indemnity period for the business interruption, and sometimes generally it's a limit on the extra expense, a monetary limit. So you don't necessarily have a limit as how long the extra expenses can go on. There's a monetary limit, but as far as business interruption goes, you generally have a 12-month period there. So yeah, I would say most definitely very good question. And I would think that brokers and insurers would have or thought of that or are in the process of doing that or have already done that. I'm not even sure.
Yeah, the submitter just said, i.e. ALS, 12 months or 18 months.
Yeah. So the short answer would definitely be yes. We don't know how long this is going to go on.
Yeah.
We don't know how long this is going to go on, I guess.
Cool. Very cool. Next question. Did replacement of the undamaged turbine shaft attract coverage?
Another very good question. The broker did press for that, and there was no sudden and accidental failure of that shaft, and this is actually an ongoing matter. We've got counsel involved, so I can't discuss it in too much detail at this point, but yes, the broker has requested coverage be afforded for that second shaft, and we have counsel involved to give a coverage opinion on that, and I don't want to go into too much detail on that, but a very good question. So yes, it did attract coverage question if that was it.
Cool. What caused the vibration in the generator?
You know what? That was an older file, and I don't think it was ever determined because we didn't tear it down. Oh, did we, or did we tore it down partially, and it was determined that the failure occurred in the alternator portion. But we didn't go to the extent to determine what was causing the vibration because we knew we had coverage. And we knew that the maintenance contractor had overlooked, or someone had overlooked, these vibrations that were pre-existing to this loss. So unfortunately, I don't know what caused those vibrations. I can't answer that question.
Okay. We have another question. This might be a little off topic, but just wondering if you're seeing higher claims costs now affiliated with refrigerants with HCFCs as they are now no longer available since January 2020 in Canada. Are you seeing an
I
increase
guess
in claim costs?
I haven't experienced a claim involving that lately, so unfortunately I can't say.
Okay,
Or
cool.
I don't know. I haven't experienced anything, any higher costs.
Okay, great. Well, thank you all. We're going to take a 10-minute break and then resume on the hour. It's actually a 12-minute break. Thank you so much, Matt. Really appreciate you joining us today. It was great case studies. We have Matt's contact information on the screen for you. Matt, if you don't mind just keeping it up for a couple more minutes, and everyone enjoy the next 10 minutes or so of a break, and we'll get started on the hour. Thank you again, Matt.
Thanks, George. Appreciate it.
Our pleasure.